So again, just to review, what is research validity? So research validity is when you have accuracy of your research conclusions. So when you get to the end of your study, and whether you reject the null or not, or attribute the effects to your independent variable or not, you're doing that accurately. And there was 4 pieces of that. We talked about statistical validity a couple weeks ago. That's just minimizing your type 1 and type 2 errors. We talked about internal validity last week. That is where you've controlled for all sources of confounding. This week, we're going to talk about construct validity for causal conclusions, and that is when the underlying theoretical constructs for the study causes, that is your IV, and effects, your DV, are correctly manipulated or measured. And so the key there, at least one of the big keys, is that your operational definitions of your study variables are reliable and valid. Next week, we'll talk about external validity. So this week, construct validity for causal conclusions. Let's do this. So construct validity for causal conclusions is when the underlying theoretical constructs for your study causes and effects have been correctly manipulated or measured. Right? You correctly measured the DV, correctly manipulated the IV. And so it's when you've properly defined and measured them, meaning not too broadly, not too narrowly, and not inaccurately. So valid research studies have both construct validity for the IVs and construct validity for your DVs. So let's switch specifically to construct validity for your IVs, your causes. When the underlying theoretical constructs for study causes are correctly manipulated and measured in your study, you have construct validity for your independent variables. So the IVs in your study must have construct validity for your study to have research validity. So one way to ensure that you have correctly manipulated or measured those underlying causes, that is your IV was well done, is to do what we call manipulation checks. So manipulation checks are used to ensure that your study has good IV construct validity. So what the heck is it? So it's when you test whether the independent variable actually varied how it was intended to vary. So for example, let's say you wanted to look at the effect of humor on galvanic skin response, GSR reactions. So one group is randomly assigned to watch a funny video, another group randomly assigned to watch a neutral video. It's not supposed to be funny. So those are 2 levels of your IV. It's sort of video type, I guess. And your DV is measuring their galvanic skin response, like a lie detector. And if you wanted to do a manipulation check, like some people really hate Adam Sandler, and some people think he's hilarious, right? So it's possible if you used a funny Adam Sandler video for your funny condition, people didn't think it was funny. So how might you see if your participants actually did perceive the funny video as funny and the neutral video as neutral? Ask them. Just ask them. It doesn't even have to, I mean, just ask it as part of your study. So how funny was this video, right? And you would expect that if the funny video was funny, the average funny rating for the funny video would be higher than that for the neutral video. So that is what we call a manipulation check. It's just sort of common sense, but a lot of people don't do it, and they find out too late that, you know, people didn't actually notice my independent variable manipulation, or they didn't think my thing was funny, etc. So keep going with the theme of construct validity for your IVs. So your independent variables can be defined in many different ways, right? So different researchers have different hypotheses for things, or operational definitions for things. So for example, you could study the effects of distraction on memory by defining distraction in all sorts of ways. It could be distracting noises, it could be distracting colors, it could be distracting data collectors, etc., and so forth. So there's lots of different ways you can operationally define your independent variables. But whatever you do, you want to make sure you avoid mono-operation bias. So mono-operation bias is when you define your IVs in only one way. What does that mean? So for example, let's say you wanted to study the effect of attractiveness on perceptions of intelligence, and for your manipulation of your IV, you use these two pictures up top. There's one picture where the person's smiling, one picture where they're not smiling, so and you want to know if they view this person as more intelligent or not, right? And the problem is you've used exactly one person. You have mono operation bias. It's the same person used twice. You don't have like multiple people smiling, not smiling, or whatever it's going to be. You have defined it in a single way. That is a mono way. You have mono operation bias. So another example, let's say you're going to look at the effect of classical music on intelligence. You've got to come up with some way to manipulate that independent variable. I assume there's like classical music, not classical music. Are you going to use Beethoven? Are you going to use Mozart? Are you going to use something else? How are you going to define classical music operationally for your study? The point here is don't just do one exemplar of it. Do multiple, right? So multiple pictures in the prior example here, you wouldn't want to just do Beethoven. You'd want to do a couple examples of classical music. So that would be avoiding mono operation bias. You avoid it by using multiple exemplars or multiple examples of your independent variable levels. So use multiple attractive and unattractive picks for multiple exemplars of classical music in the examples above. Let's switch over to construct validity for our dependent variables. That is construct validity for our effects. You have construct validity for your DV when the underlying theoretical constructs for your study effects have been correctly measured. So in other words, the DVs in your study have construct validity. It's important for your study to have a research validity. So you have to have construct validity for your DVs for your study to have research validity. Otherwise, like, what were you measuring? So for example, what if your questionnaire that's supposed to measure prejudice really just measures social desirability, because that's how people respond to it. So you want to ensure that you are truly measuring what you intended to measure. That is, you want to have construct validity for your DV. What if you use self-reports and they differ from what people actually believe? So you have people self-reporting things and they're just making crap up. They're using response sets. You've got bad construct validity. So response sets where you're not actually capturing how people really believe or feel, that would be bad construct validity. So another one we haven't talked about yet is retrospective accounts. Is a bad way to do research. Like, don't do this if you can avoid it. So retrospective accounts tend to be unreliable and valid. So what is a retrospective account? Answer this questionnaire pretending you're a teenager. So we'll actually analyze one of these next semester. So, take this pretending you're 18 is a really bad way to do a study. Why? Memory is constructive and biased. That's why. So try to avoid retrospective accounts if you can. Another thing we have talked about before is you never ever want to use a single item as your measure for your whole DV. So we talked about this during the reliability and validity lecture. You want to use multiple questions. Multiple questions are, you get a more reliable for sure, but hopefully also therefore valid measure of your DV. Do not just have like 1 to 10 like I got here. How attractive is this person? Don't do this. Use multiple Likert scales that you sum over, or multiple questionnaires, etc., or multiple measures of your DV, just sort of period, other ways of measuring it to ensure that you have good construct validity for your DV. So, for example, when I was at DMV, we get these calls from the legislature to do a study at good driving or something like that, or bad driving sometimes. And we would never just measure one thing. That is it's kind of like a mono operation bias for your dependent variable, right? We would measure multiple things. So when we did a study, we'd look at the participants, maybe their drive test scores, their written test scores, for their knowledge test, numbers of crashes they got in, number of tickets they got, we'd collect all these different ways of defining the dependent variable, but they're all sort of measures of good driving. And what you look for is what's called triangulation. You look for the results to triangulate, and that is when you have different operational measures of the DV, and you look to see that the IV has a similar effect across the different measures. So, the group you thought would do better does better on all or most of your DV measures than the group that you didn't think would do as well. And that is a great way to ensure that you have construct validity for your DV. So a couple more things about construct validity for the DV is overall bad DV measures lack what we call discriminant ability. So if things don't vary, you can't detect differences between groups. You have restricted variability. So let's talk about some ways that DV measures can result in restricted variability. Oh, sorry. So first, measurements of the DV must vary to be useful. Like if everyone gets the same score, you can't detect differences, or too high a score, too low a score, or just junky scores, right? So effects that reduce your variability weaken your DV's construct validity. Here we go. So there's something called ceiling effects. And so what ceiling effects are when measurements for practically everyone are too high, so there isn't a whole lot of variability. So it's like the red thing, the red distribution at the top up there. Everyone got a really high score. Just a couple people got low scores, and so you have this sort of smushing of variability. You don't have good variability in their responses. That's called the ceiling effect. Everyone gets too high of a score, and it will reduce your construct validity for your DV. So, for example, what if, for whatever ridiculous reason, you're doing a study with college students, and you test their mathematics ability in your study, and your operational definition for that is just a bunch of addition problems, like simple addition problems. Well, they're all going to do really well, and whatever your independent variable was, you're not going to be able to detect differences anyway, because everyone's just going to do great, regardless of your DV. You're going to have a ceiling effect. So the opposite of that is what we call a floor effect, and this is where everyone blows it or gets a low score on your dependent variable. And so again, the problem is if it's like the blue distribution up top. Everyone gets a low score. There isn't much variability across the full range, and so you can't detect differences between your groups, and you have cruddy construct validity for your DV. So that would be the flip side of the prior example, where you're doing a study with grade school students on their mathematics ability, and you have them all do crazy algebra problems. Everyone's just going to blow it, right? So you're going to end up with a problem with variability and therefore construct validity for your DV. Everyone's going to get a low score. We call that a floor effect. Then there's what we call instrument drift, and this is when your data collection instrument changes in accuracy over time. And the problem with things changing over time due to reasons other than your independent variable is that you don't get a uniform measure of things over time. It's sort of drifting over time, and it usually gets worse over time. And that means you have unreliability. And as you know, unreliable measures can't be valid, and so therefore that degrades your construct validity for your DV. So just as an example, for some reason you got something that uses batteries on a scale and you're weighing things or weighing people, and over time the batteries wear down, you get cruddier and cruddier, less accurate ratings over time. That would cause this sort of problem of instrument drift. Or maybe you have a camera as part of your study and you actually need to adjust it because it kind of shifts over time, and you fail to do that, you're going to have a slow sort of degradation in your DV measurement over time. That is instrument drift, and it messes up your construct validity for your DV. So there are also researcher effects on your construct validity. So just a little bit of review from last week, but researchers are not unbiased. They're not disinterested parties. And we tend to be biased in favor of particular results. Like you're going to want to find, it's really hard to not want your hypotheses to be supported. And so you may intentionally or not affect how your participants respond to things in your study. So how do we reduce this again? We use double-blind procedures if we can. So to avoid having researchers sort of on purpose or not, affect your findings and procedures. And so what was double-blind? Neither the participants nor the researchers know which condition each participant is in. So if they do that, they can't sort of influence them, right? So also, back to like a biosocial effect, is participants react differently to different data collectors, right? So, for example, they may answer questions more honestly for data collectors of their same sex, right? So, particularly if you're asking about something that is they may not want to answer or give you honest answers on, it's sort of like a variation of mono-operation bias. So to reduce your data collector bias, you want to do a couple things. Use uniform instructions. If you use multiple data collectors, you want to balance them on things that might be important. Say if you thought the sex of the data collector would be important, you want to balance that. Or better of all, just don't use data collectors that are real people. Just use pen and paper or internet surveys if you can, or archival data. That is, you depersonalize your data using surveys, that sort of thing. So finally, just continuing on with our researcher effects on construct validity, there's also something we haven't talked about. We talked about paradigms, which are sort of broad views of seeing the world. There's also something called investigator paradigm effects. And this is when you lack construct validity in your study because the researcher is based on their paradigm, their broad set of beliefs, asking the wrong questions or using the wrong data to explain, or theory to explain findings that they get. And so a piece of that is what we call conceptual bandwagons. So this is sort of dogmatically following your particular belief structure, and that can cause you to not see the world accurately. So, if you have a very strong belief about things, everything you see, you might interpret through that lens, and it could reduce your construct validity for your IV or your DV. So the way to sort of colloquially say that is when your only tool is a hammer, everything looks like a nail, and that can result in problems. So, for example, the early behaviorists refused to interpret findings that persons could learn by modeling instead of direct reinforcement. So even though, that whole Bobo doll thing where they watched other kids beat the blow-up doll clown thing, they just refused to interpret those findings correctly, that we don't have to learn directly. We can learn through modeling, that is watching other people. So how do you avoid the investigator paradigm bias? Well, you can use what's called an eclectic or a multi-theory approach to doing things. So because no one paradigm explains all phenomena out there, you want to be flexible and borrow ideas from other areas. So for example, most therapists don't use just one type of therapy. They use whatever therapy is the best for the particular condition of their client. So, CBT for certain things and rational emotive for other things, etc. So you want to be flexible and not just subscribe to one particular paradigm, and that's what we call a multi-theory or eclectic approach. So that's it for this week. The take-home message is things which threaten your construct validity for causal conclusions will also threaten your internal validity of your study. If you're not manipulating and measuring things that you properly, there's no way that what you thought would have an effect on your DV can, because you don't even know if you measured it correctly. And if, manipulated it correctly. And if you have bad construct validity for your DV, same thing holds. If you didn't even measure what you're intending to measure, how can you have internal validity for your study and conclude that changes you see are due to your independent variable? You don't even know what you measure. So that is it.